Hello everyone. Welcome to this video about operational congestion management. My name is Jochem Bronkhorst and I work at Alliander in operational congestion management. In this video, I will explain the core loop of short-term operational congestion management and how we use it to guarantee system safety. I also want to bring together the context and concepts you have seen in the previous videos and create a basic understanding of the interaction between forecasts, grid limits, and customers using a practical example. For congestion management, we often use something called a congestion graph. A congestion graph is always built on a safety assessment performed at a certain moment in time. That safety assessment describes what we expect ahead in time, so it's short term, day ahead, and close to real time. Let's take a simple example. We look at a specific part of the grid that delivers electrical power to households. For example, consider a 10 megawatt station that could supply a few thousand households. And those households can both consume power and produce power. So flows in both directions are possible. Within this grid, we also have limits. In our example, we keep it really simple. We say it's a 10 megawatt station, so the congestion limit is set at 10 megawatts all the time. In reality, limits can be much more complex, but this is enough to explain the idea. What do we do next? We generate a short-term energy forecast. That forecast is a key ingredient of the congestion graph because it shows what we think will happen in the future. Now we see the forecast going outside the congestion limit. That means at that moment in time in the future, we can expect an overload to occur in this area in the grid. So we have a congestion problem here that we need to manage. Here it's an excess in production that will exceed the limit. A bit later, as we update the forecast, we can see the forecast evolving, but we still see a clear peak, say between 12 and 4 o'clock. That's usually a solar peak. Now, how do you solve that peak? We use concepts you've heard about before, demand response products. At a certain decision moment, typically day ahead, we decide whether to activate a flexibility product. In this case, we have a strong forecasted production overload, so we need to either reduce production or increase consumption in this grid area. Increasing consumption is quite difficult, since most consumption comes from direct behavioral choices. Reducing production tends to be much easier, whilst generally speaking, turning off a solar PV field is less disruptive than asking an industrial facility to double consumption tomorrow. For any request we do, we are trying to change someone's behavior from what they would naturally do. In the Netherlands, one option is a capacity limiting contract for a specific customer. Let's take this day as an example. On the 30th of March, we forecast a fairly large production peak. Under the contract, the client normally has a certain allowed capacity, say 5 megawatts in this case. But if we go one day ahead, using the contract, we can reduce that allowed capacity for a limited amount of time. This means we create space to reduce the local production peak, which is exactly what we want here. So we call the client in the day ahead window, and importantly, we already agreed in a contract that defines how we interact. It defines expected effect, it defines the financial compensation the client will receive, and those things are agreed in advance, so we don't have to talk about it in the moment. So after the call, the client steers its behavior according to the agreement. Then the day itself happens, and now we switch from forecast to reality. Measurements start coming in. On the congestion graph, you can see the measured line in black, and you can see that it stays within the limits. That was our goal, and we achieved it. You can also see the steering action clearly. Before 12 o'clock, the curve grows quickly, and then there's a jump or change. That is the effect of our intervention. If we hadn't steered, the curve would have been outside of the limit for several hours on this day. Also an important reminder, heating is what ages your assets, and heating goes with the square of the current. So if you lower your peak current by 20 to 30%, the reduction in heating can be very considerable. That's why peak reduction and also peak height matters so much. Now, what was the effect on the customer whose behavior we changed? If we look at the customer measurements, you can see the same general pattern. but with a clear hole in the period where we ask him to limit production. That hole is the part of the agreement we compensate financially. And after the action, we verify whether the customer actually did what they agreed upon. This is how we check performance and settle the contract that we agreed in. So in essence, operational congestion management has 3 pillars. First, we forecast the problem. Second, we intervene when needed. And third, we check and verify afterwards whether the intervention was delivered. Now, in this video, we describe the core loop of operational short-term ahead congestion management and how it helps guarantee system safety. We looked at how operators forecast grid conditions, detect potential congestion, and take corrective actions to keep the system within its limits. We also analyzed the complex interaction between forecast and customers in achieving a reliable energy system. Customer behavior affects demand and flexibility, while forecasts help operators anticipate changes and respond in time to maintain a stable and reliable energy system.